When dividing, let's say we have 15.92 divided by 6. Now, for the over-under method, we're going to have a little work on the side. So we're going to have an over list, and we're going to have an under list. Our over list always stays the same. No matter what problem we're going to work on, our over list will always be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Our under list all depends on our divisor. We're going to end up counting by this number. In this case, we have a 6. So we're going to count by 6s. 6, 12, 18, 24, 30, 36, 42, 48, and 54. Now that we have our over-under list, we're actually able to look at our division problem. So we're starting off with a 1. We need to figure out how many times does 6 go into 1. So we're going to look at our under list, and we need to stop whenever we get to the 1 or the number closest to 1. But starting off, we hit 6, and that's bigger than the 1, so we can't do anything right here. It's a 0. Any amount of 6's is more than the 1. So we're going to have 6 times 0, that's 0, and now we subtract. 1 take away 0 is 1. We're now going to bring down the 5. We only bring down one number at a time. Now that we have this 15, we're going to repeat the process of using our over-under list, but now we're focused on 15. So now we look at our under list. Where is the number that is either equal to 15 or a little smaller than 15? That's right here at 12. So under our division problem, we're going to write 12. And over the division problem, we write a 2. We go directly above the number that we brought down, so we write a 2. We're going to subtract. 5 take away 2 is 3. 1 take away 1 is 0. So now we have a 9, which we're going to bring down because we're not done. We're now looking at 6 into 39. So looking at our under list, we're looking for either 39 or a number close to but smaller than 39, and that would be 36. So under our work, we're writing 36, and over the work and our division problem, we're going to write 6 over the 9 that we brought down. We're going to subtract. 9 take away 6 is 3. 3 take away 3 is 0. We're not done. We have a 2 to bring down, so I bring down the 2. So now we have 6 into 32. We're going to look at our over-under list now for 32. So what number is under or equal to 32? That is 30. So 30 goes under the 32. And over our division problem is 5. We're going to subtract. 2 take away nothing is 2. 3 take away 3 is 0. We're not done because we still have the 2. So now we're going to add a 0 and bring it down. We're now going to be looking at our over-under list using 20 as the number that we're working toward. So where is a number equal to or less than 20? Well, that would be 18. So under our 20, we're going to write 18. We're going to end up subtracting that, but we need to remember let's put our 3 over 20. Take away 18 is 2. We're not done. We need to bring down another 0 because we still have something left over, which is a 2. And now we have 6 into 20. But we already had a 6 into 20. So that means we would end up getting a 3 again for 18, which means actually the 3 never ends. It's going to repeat. So I'm just going to put the repeater bar above our 3, showing that it really keeps going on forever. As the final step, we need to remember to take our decimal and move it straight up. And that way we have our answer. 6 goes into 15.92, 2.653 repeating amounts of times. We just saw an example of the over-under list being used with 6s. So now I'm going to show you the over-under list when we're working with 7, just to show you that while the over list always stays the same, the under list will change. So in this case, we're going to work with 1,438.5 divided by 7. So for our under list, we have to count based on 7. So we have 7, 14, 21, 28, 35, 42, 49, 56, and 63. We're now going to look at 7 going into 1. Where do we reach 1 or less on the under list? Well, we don't, because the first number is 7. So 7 goes 0 times into 1. 7 times 0 is 0. 1 take away 0 is 1. We're going to bring down the 4. And now we're looking at 7 into 14. So looking here, where do we hit 14 or less? Well, 14 actually shows up in our under list. So we're going to write 14 underneath the 14 and above the 4 that we brought down. Over it, right here, we're writing our 2. 7 goes twice into 14. We're going to subtract 14, take away 14, we get 0. So now we're going to bring down the next number, which is 3. Looking at the over-under list this time, we're going to be focused on 7 going into 3. So where does 3 show up? Well, it doesn't. Once again, 7 is the smallest number, so 7 goes 0 times into 3. We can't do that. 7 is too large. So when we say 3 take away 0, we get 3, and now we bring down 8. We're focused now on 7 going into 38. So looking at the over-under list for 38 or a number smaller, well, here's a 30 up to 42. 42 is too large, so we're going to go with 35. Under 38, I'm going to write 35. And over the 8 that we brought down, 35 is associated with 5. So I write 5 over our division problem. I'm going to subtract 38, take away 35, I get 3. I bring down 5. And now we're looking at the over-under list for 35. So on the under list, 35 shows up. So that is equal to 35. So I'm going to write 35 underneath the 35. And 35 above the 5 that we brought down, I'm going to write a 5 because that's the connection on the over side of our over-under method. 35 take away 35 is 0. Our final step is to take our decimal and bring it up, straight up to the top. And so we see that 7 goes into 1,438.5, 205.5 times.